Alright, so here's what I'm going to do. Here's my hot air balloon. Beautiful hot air balloon. Boom. We know that it's rising up from a level field. So this is what we know. It is going on that direction. It's going up. Agreed? From the ground. What else do we know? It says a hot air balloon rises to, we have a range finder 500 meters from the lift-off point. So this is where it started. I'm just going to go, it doesn't matter what direction you go into, but I'm going to go in this direction, and I'm going to pretend this is my range meter. So there's my range meter. Here's my balloon. Okay? At that moment, then we have an elevation. The angle is 45 degrees. So here's what I know. I know that this thing is measuring the angle. I'm not going to notice how I'm not putting any type of actual measurements just yet. And here, I'll talk about it why in just a second. But more importantly, I'm noticing that I have a right triangle. Okay? Then I'm going to actually fill out the information that I do know and what is asking me to find. Okay? We know that it's 500 meters from the lift-off point. Is those 500 meters ever going to change? So then you're going to just write it down as 500 meters. We have this balloon that is going up. Is that distance going to change over time? So it's not a set distance, agreed? So you're going to have to use a variable for it. Let's use y since it's going up. Why not? Doesn't matter what variable you use. Now, the other piece of information that was included here was that there was an angle. Is that angle going to change as your balloon rises? So instead of putting the 45 degrees, I'm going to put theta. Okay? Alright, so now I have a good sketch of what this looks like. Now I need to come up with some kind of equation that can help me figure out, in this case, how fast the balloon is rising. So I'm looking for how fast y is changing. Agreed? Now, I have an angle on a right triangle. I have the opposite side and I have the adjacent side. Tangent of theta equals what? Y over 500. Agreed? Okay, here's what we know. We're going to go back to the problem and write down the other information that was very specific that we need to know in order to solve the problem. It says the angle is increasing at a rate of 0.4 per minute. So that means the angle is changing, right? So remember how I told you can differentiate in terms of any variable? All of these types of problems, you're going to have to differentiate in terms of time. Because as time changes, things are changing. So we know that our angle is changing in terms of time. So d theta dt, 0.14 radians per minute. Okay? That's what we know. We have another piece of information. It says that at a very specific moment, remember how I say instantaneous, you need to know a point? Well, at what point? When theta is 45 degrees or pi over 4 radians. Okay, so we know that theta is pi over 4. We need to find out when that angle is pi over 4, what is how fast the balloon is rising at that moment. So because we have this, basically this is the position in a way, right? We can think about it that way. And we need to find how fast something is going. We need to find its velocity. Then we need to derive this. Agreed? Okay. How well do you remember your derivatives of trig? What's the derivative of tangent theta? Uh-oh. Do you guys not remember it? The derivative of tangent. It's secant squared theta. And because we're taking a derivative in terms of time, that means that I have d theta dt, right? Equals, now, couldn't I just rewrite this as 1 over 500 times y? And then that becomes easier to derive rather than doing a quotient rule here? What would you say the derivative of this is then? So I'm going to rewrite it just so you guys can see it. Instead of saying y over 500, what if I rewrite it as that? Then let's make sure we understand. That is the same thing as that. This is a lot easier to derive than that because this would involve a quotient rule. And this just involves a power rule. 1 times 1 over 500 is, and the power goes down by 1, so then the y's go away, but we have dy over dt. Correct? Alright, so at this point it's like, okay, I derive all this. Now you're just going to plug in the information, okay? First of all, since we're looking for how fast the balloon is, aren't we technically looking for dy dt? That's what we're looking. Agreed? That's what we need to find. How fast is that changing? Alright, we have this all, I mean, you could kind of try to isolate dy dt if you wanted to. You're welcome to do so, but you don't really have to. I would just start plugging in information. Okay? Alright, technically this is the same thing as saying secant of pi over 4 squared times, what is d theta dt? Well, d theta dt is 0.14 equals to 1 over 500 dy dt. Okay, here's where your trick comes in very handy. What is the secant of pi over 4? Well, we know that it's going to be the reciprocal of cosine, right? And the cosine of pi over 4 is root 2 over 2, so then that becomes 2 over root 2 times root, so 2 root 2 over 2, the 2's goes away, so the secant of pi over 4 is root 2. If I square that, it's going to become right? Now, can I multiply both sides by 500? So if I multiply by 500, that goes away. And I know now that dy dt is, well, 500 times 2 is 1,000 times 14 is 140. But this is very important. They're going to look for you to be able to answer this. You have to have units. What would be the units? Well, what does dy dt represent? Does it represent the angle or does it represent the distance that is rising? So it's a distance. What were the units? Meters per minute. Because you had over here radians per minute, right? So, alright, let's kind of summarize what we did. There was a lot. Okay? Drawing a picture is going to be essential for this problem, guys. It doesn't have to be a piece of art. Just, there you go. That's simple. Then, always write down what you know. And write down what you're looking for so that you know where it is that you're trying to get. Once you have your picture and what you know versus what you're looking for, then you can kind of look at your sketch and say, well, how is there any kind of equation I can come up with the information that I have? So on this one, because I had the angle, I thought of doing tangent. If I didn't have the angle, maybe I could have thought of Pythagorean theorem. So you're going to have to actually think this through. What equation would help you figure out what they're asking for? Okay, and we're going to practice a few. Questions over the first one? Alright, then let's try the second one. A police cruiser is approaching a right angle intersection from the north, is chasing a speeding car that has turned the now moving straight east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determines with radar that the distance between them and the car is increasing at 20 miles per hour. If the cruiser is moving at 60 miles per hour at the instant of the measurement, what is the speed of the car? There's a lot going on in here. I don't see how you can do this without a sketch. Alright, first let's start with where the problem is. Here's my police car. There's the police. It says it is approaching a right angle intersection from the north. So here's what I know. It is going from the north, so that means it's going towards the south. Agreed? It's going in that direction. And it is approaching a right angle intersection. So that means that it's going to be perpendicular to his direction. Agreed? So here's what we know. Here's the intersection. And it's perpendicular. It says it's chasing a car, and that car has already turned, and it's going towards the east. So the east will be down here, right? So this is the car. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 east of, the police determine that the distance between them and the car is increasing at 20 blah blah. If the cruiser is moving at 60 miles per hour at the instant of the measurement, what is the speed? Okay, you've seen, hopefully most of you drive. If you don't, in order for the police to catch your speed, they point the radar at you, and it's kind of like a gun. If the police is going to shoot the radar at him, it has to point it on this direction. Agreed? In order to catch that person's velocity. Interesting. Another right triangle this time. Here's my question to you. Do you see anything about an angle this time? You don't. So here's my question to you then. If this police officer is going on this direction, that means this is going to be changing. So it's not constant. So we're going to call it Y. If this car is also moving, it's not constant. So we're going to call this X. Using your common sense, is this going to be changing? If this changes and that changes, would the hypotenuse change? Agreed. But we don't know that, right? So we're going to assume that it's changing. So then you're looking at this and everything is changing, and you have a right triangle. What kind of equation do you think would work to figure this out? Plus y squared equals z squared. Could you have used a, b, and c, or any other variable? Sure. So now we have the sketch, we have this drawing. Let's find out what information we know. We know the cruiser is 0.6 north of the intersection. So that means that this is 0.6. Agreed? The car is 0.8 miles to the east. We know that this is 0.8. So I'm going to go with what I know. Here's my notes. I know that y is 0.6. I know that x is 0.8. Do we know what z is? We don't, but I would suggest maybe finding it. Well, we know that z in this case is going to be the square root of 0.6 squared plus 0.8 squared. Agreed? We don't have to solve it at this moment, but that's what we know. Alright, we're going to keep reading. The police determines with the radar that the distance between them and the car is increasing at 20 miles per hour. If the radar is shooting on this direction, that means that this is a derivative, right, in terms of time. So we know that d something over d time equals 20. We are going to call it. Which one are we talking about? Are we talking about y, x, or z? Z, because it's the radar, right? He's holding out his radar. So as he's holding out his radar, he's still moving, right? Okay. So dz dt is 20. If the cruiser is moving at 60 miles per hour, so this is going to be d something over time is 60. What would that be? dy over dt. Which leaves us with one last thing. What is the speed of the car? That means I'm looking for what? dx dt is unknown. If you have your picture, you have your knowns and your unknown, then the problem just becomes relatively simple. You just have to stay organized. I have to derive this thing. 2x dx dt plus 2y dy dt plus 2z dz dt. Agreed? We derive everything, not plus, my mistake, equals. That was my mistake. I'm sorry. We derive everything implicitly, and now all we have to do is plug in the information that we know. But just to make this problem even easier, do you guys agree that I could divide by 2 and get rid of all those 2's? So this could actually just become x dx dt plus y dy dt equals to z dz dt, right?
Do you have to write dy over dt, or could you put y prime x prime z prime, or do you think they want to know that you know that
Because this is a test, I would suggest that you communicate that you know that this is in regards to time. So I would suggest that you actually do dy dt. Okay. Now we're just gonna plug in what we know. Do we know what x is? So it's 0.8. Do we know what dx dt is? No, we don't. That's what we're looking for. Plus y is 0.6. dy dt is 60 equals to z. Well, we're actually gonna need to figure out what z is. If I get rid of those variables, just looking at that, that's 6 squared and that's 8 squared. 6 squared is 36. X squared is 64. 64 plus 36 is 100. So if I put back the derivatives in there, that would be 1, right? Square root of 1 is 1. So z is 1. And dz dt is 20. Alright, so here's what we know. Dx dt is going to be equal to 20 minus, well, what's 0.6 times 60? What is it? 36. Right? And we have to divide by 0.8. Agreed? The 20, 0.6, and the 0.8. Alright, so at this point, 20 minus 36 is negative 16 over 0.8. So that means what? 20? I have a problem with that. Okay? And mathematically you did everything correct. I just wanted to see if anyone was going to catch this. When you are doing, think of this as vectors. The direction in which things are going matters. If you're going south, that means you're going down. How can you tell the direction? If you're going to the east or going to the right, is that going to be positive or negative? Positive. So in case you forgot, just put yourself a little reminder. If you're going that way, down or to the left, it's going to be negative, right? If you're going up or to the right, it's going to be positive. Now, let's figure out how much of a difference that makes, okay? Because the answer we got was that the car was traveling 20 miles per hour. Agreed? And the cop is going to catch him like that. If it's going 60, it's going to catch him relatively quickly. Agreed? Let's see how much of a difference it makes putting that negative in. So that makes this a negative, right? Do you guys agree? Okay. So then instead of having negative 30, this is going to be plus 36. Agreed? You guys with me? So then instead of having negative 16, I have, what's 56? Well, 56 divided by 8, isn't that 7? But because it's point, wouldn't that be 70? That's a huge difference. From going 20 miles an hour to going 70 miles per hour. That cop better speed up, or it's not going to catch up to him. Agreed? Alright.
Wait, so how many points do you get off if you put negative?
It all depends. One of the things like we will talk about, and I will show you when we do that sample problem, I'll show you the problem and I'll show you the way they score it. It all depends on the way they score it, and it all depends on the person that wrote the test that year and how they want to distribute the points. So I don't have an exact answer for that.
Well, is it usually more points for your work and one? It's usually more points for your work and less points
It's
for
typically more points for your calculus because they're testing you over your calculus than it is for your algebra.
so you probably would get some credit.
Agreed. Okay? So do you guys see how you have got to make sure that direction is going to come into play here? If direction is part of your problem, then you got to make sure that you use your negatives. Because we went from having 20 miles per hour to 70, which was a huge, huge difference. Cool? Questions on this second problem? Alright, I'm going to do one more with you, and then I'll let you try one on your own. Okay? Alright, air is being pumped into a spherical balloon. Ooh, fun. So that its volume increases at a rate of 100 cubic centimeters per second. Excuse me. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? Alright, here's my awesome balloon. What's changing in here? The volume. So that tells you you're going to need the volume of what? Do you remember what the volume of a sphere is? 4/3 what? Pi r cubed. Very good. You may be asking yourself, am I going to need to know these formulas? They are expecting you to know the volume, so if you can write this down, the volume of a sphere, a cone, and a cylinder. Those three. So if you want to write them down, volume of a sphere is 4/3 pi r cubed. Does anyone remember the volume of a cone? One-third pi r square. Pi r square is the base times the height of your cone. And the volume of a cylinder is area of the base, which is pi r square, times the height of your cylinder. So those three are the ones that they expect you to know. Okay? But I'm going to be honest, I asked Mr. Crone about this, and he says that sometimes they even give them to you within the problem. Okay? If it's something that it's not one of those, they'll provide it for you. Alright, so we have our sketch, we have our formula. Now what do we know? Here's our knowns. We know that the volume is increasing at a rate of 100 cubic centimeters per second. So that means what over dt? dV equals 100 cubic centimeters per second. What else do we know? The radius is what? 50 centimeters. And that's all we know. What is it asking us for? Yes, sir. Oh, good catch. The diameter. Sorry, diameter is 50, which means that the radius is 25. Agreed? Good catch. Alright, that's all we know. But what is it asking us to find? How fast is the radius changing? So that means I'm looking for dr dt. How fast is the radius changing over time? Alright, go ahead and try that one, and then I'll show you the answer in just a second. So I got you started, now you finish it up. We all found out that the derivative in terms of time is dv dt equals 4 pi r squared dr dt. Ultimately, when you simplify things out. Agreed? Because 3 times 4/3 is 4, right? Leaving you with just 4 pi r squared dr dt. Now from there, I just plugged in what I knew. I knew that dv dt was 100. I knew that the radius was 25, and I was looking for dr dt. So then I simplified and I say dr dt is the same thing as saying 100 divided by this entire mess right here. Agreed? 4 pi 25. But notice how I rewrite it, and it's just a trick. You don't have to do this. So I know that 25 squared is the same thing as 25 times 25. Agreed? So technically 4 pi 25 times 25 is the same thing as 4 pi 25 squared. Well, here's why I did that. Because then I went back and I rewrote 100 as 4 times 25. Is that 100? And the reason why I did that is because then at that point you can say bye-bye 4s and bye-bye 25s. leaving you with 1 over 25 pi. Which, if you did all the algebra, you would still get the same thing. Like, if you actually did 25 squared, that's 625, times 4, 2,000 something, right? And then you're going to have to divide 100 over that. I promise you it's going to be 1 over 25 pi. Okay? You can manipulate anything algebraically as long as it's true, right? What's up? The 3? Right here, if I do the this, the 4 over 3? Well, here's what's going to happen. If you do this times that, right, it becomes, let me go to the side, it becomes dv dt is equal to 3 pi times 3, which is the 3 that I brought down, right, r square dr dt. Do you follow me? Like, all I did was bring this 3 down, and I need to multiply it by this, right? And then the 3 goes down to a 2 on the power. Well, what happens here is that if you do 4/3 times 3, cancels it out, leaving you with 4 pi r square dr dt. Cool? So I like to simplify, especially on these types of problems. Sometimes if I'm able to simplify some of the things at the beginning, just to make the math more simple. Okay? And then from there I just plugged in. And then again, you didn't have to do the steps that I did here. You could have actually found out what all this was. Like 25 squared, 625 times 4. Well, 25 times 4, that's 100. 600 times 4, well, 6 times 4 is 24, so 2500. And then 100 over 2500, that's the same thing as 1 over 25. Cool? Questions on the second one? Alright, I want you to try the next one, but I want you just to set it up. We're going to work it together because there's a trick to this problem. I want you to draw yourself the picture, I want you to write down what you know, and I want you to come up with the equation that we're going to derive. Okay? So just set up the problem, and then we'll work it together. Alright, let me repeat that one more time. We're going to use the concept of ratios to figure out how can I rewrite r in terms of another variable that's present here. As the water increases, we can use the ratios because we know that the maximum height you can get is 10, and we can compare that to any height on the cone. The maximum radius you're going to be able to get is 5, and we can compare that to any radius. If we solve for r, so I cross multiply here, I get the r equals h over 2. And then we're going to use the concept of substitution. And I am going to go back into this equation and rewrite it. This is going to become volume equals, but instead of r square, I'm going to say h over 2 square times h. Because we now know that r is h over 2. Okay? Yep. I think there's another way to solve it. This is the easiest way I can think of. Okay? You could find dr dt, I believe. Like if you wanted to go in the direction which Grant was saying, if we found out the radius and then find dr dt, I think you can go in that direction. I think this just makes the problem easier because you don't have to go and find more information that's not there. From here, let's just differentiate. Okay, so you have to be careful. So this becomes dv dt equals. Alright. Couldn't this technically be rewritten as h to the third over 4? Do you guys agree? Before we go on, make sure we're all there. So I'm going to just rewrite it. Volume equals 1/3 pi. The square applies there, so h squared times h becomes h to the third over 2 squared, which is 4. You guys with me? All I did was rewrite it. So if you want to even rewrite it even further, I could say pi over 3 times 1/4 h to the third. Agreed? Just for those of you that kind of need to see the power. Now, can we differentiate at this point? dv dt equals pi to the third is not going to go anywhere, right? You guys agree? Pi over 3, I'm sorry. So 3 times 1/4 is 3/4 h squared dh dt. Agreed? Alright, from here, I mean, we can simplify more, but I'm just going to start plugging things in. I'm running out of room. Alright, do we know dv dt? Sure do. It's 9. Do we know what h is? It's 6. Okay, so I have 6 squared is 36. So here's what I know. I have 3 pi over 12 times 36 dh dt. That's with me? This 3 pi over 12 is 3 times pi, and 4 times 3 is 12, right? And then 6 squared is 36. Cool? Now, I hope you notice that 36 is divisible by 12. How many times? So that cancels and it leaves you a 3. So that means, I'm going to go in this direction. 9 is equal to 9 pi dh dt. Agreed? Which means then that dh dt is equal to 1 over pi. What units would you use in this case? Per minute. There's going to be a problem like this on your homework where you're going to have to change one of the variables in terms of the other. Okay? So be on the lookout for that. Questions so far, guys? Are you feeling a little bit more comfortable with these problems? If you follow the strategy, you'll get to the answer. Okay? So I'm done with the notes. I will post the answer key to the last 2. I want you to try those 2. The homework will also be on the Learning Hub. Okay?